Ladies and gentlemen, welcome once again to the Kerbal Space Program. Today we are going to send an astronaut to the moon. We're not going to land there, but we're going to orbit for a little while and conduct a bit more science. Before we do that, though, let's go over to our research development area because we now have enough science to grab a new research tree item. For those of you wondering why my science is so high, well, I did a deep space mission. I did a flyby to the moon, and actually earlier I did take a brief trip to the desert with the Polar Mercury 3 rocket. So I should have all that data, and that equated to about 182. So we can get us a couple more things before we go on our way. I'm personally going to grab this one, Advanced Exploration, because it allows us to grab more science, which will make us get to this tree faster. Particularly, one item that I'm interested in, let's see, is going to be this barometer here, because barometers give us science, and it's a new kind of measurement that we can do that will allow us to measure anything. So, just like a thermometer, we'll have to, by anything, by the way, I mean measure, anywhere, rather. As long as we're within an atmosphere of a planet, we can do barometer science. Anyway, in order to get us there, we're going to use a new rocket that I've developed called the Luna 2. Unlike the Luna 1, Luna 2 is designed to send an astronaut there. We've replaced the Luna 1 probe with this capsule. Otherwise, the design is more or less the same. But before we leave, I am going to add a couple of scientific instruments onto this device. We've got a thermometer on one side, and on the other I would like to use our fancy, handy-dandy new barometer. Let's see, let's pop that right here on the opposite side of the thermometer. It can be a little bit higher. I don't think it matters that much, but I don't know, a little bit of symmetry goes a long way. We've also got some other items recently from our recent technology tree, including, let's see, as far as science goes, we also have what's called a mobile processing lab. A laboratory is what we could do to conduct more science in space. This is significantly heavy, if I can show you. This is a heavy, heavy item. I don't think I'm prepared to send it off into space yet without advancing in the technology tree enough to get more powerful rockets. Although it might help us to begin a space station project if we decide to do that. I'm not sure if we'll be building a space station. It might be handy to have, but I'm not sure yet. I don't see any reason why not to, I suppose. But my initial plans right now are to at least reach all of the moons and start to spread Kerbal influence across our Kerbal system before we move on to the planets. Anyway, that's about as much as there is to say regarding this mission, so I believe we're just gonna get started. Luna 1 is slated, Luna 2 is slated for launch. Let's see, just like before, we're gonna hit T, shift to put our throttle all the way up. 3, 2, 1, ignition. The procedure is actually very much the same as what we were doing before with Luna 1. Actually, up until we actually arrive at the moon, it's going to be precisely the same. Although, actually, real quick, what I can do is I can do some barometer pressure here. There we go. 84 science. On the way up, I'm also going to get some thermometer data. I already did that. Throttle down. Keep an eye on where the periaps of this particular encounter is, and stop. There. Actually, that's a little bit better than I was aiming for my line there. So now we are on a trajectory to the moon. We will need to do another burn once we arrive at the moon in order to attain an orbit there, wherein we can conduct our science. So, let us once again approach. We are going to say goodbye temporarily to the planet, but we intend to fully return because we have not only a bunch of science, but an important person with us. Our astronaut friend. Let us speed up time a tad bit more until we get to its sphere of influence. When we do, I will adjust the orbiter, our orbital path, to put us in a stable orbit around the moon, like so. Okay, slow down. Before we actually arrive at the periapse, I believe I'm going to... you know what? Before I do anything else, quick save. I'm going to try a maneuver in which we slow down until we put ourselves in an orbit here. You know, I might even be able to do this sooner and do less fuel. I'm going to try it actually over here. 13 minutes, that gives us plenty of time. Oh, that's not good. I put our periapse within the moon itself. If we try to do that, we will crash, so that is not a good idea. I want our apoapse to be about... I want our periapse to be around 30 or so kilometers to the surface. That's way too close. Well, actually, I want it to dip just below 30. Like around... yeah, well... about 30. Yeah, we'll commit to that. Maybe even a little bit less, because we don't need to get that low to conduct our science. Fortunately, I don't think it's going to require nearly as much fuel for us to burn. According to the estimate, it only says 30 seconds. So, let's see. I want to orient the craft first, so that we may safely arrive in orbit. Watch as the moon looming in the distance comes ever closer to us. Oh, there's Kerbin way the heck over there. Let's see, let us now quickly speed up time so that we can conduct our orbit correctly. Our orbiting maneuver by firing retrograde. Retrograde, by the way, means that I'm firing while facing backwards, so that we slow down our speed, which will put us in orbit around the moon. There's another term called prograde. That means that we would, actually, I'm going to quick save right here, because if I botch this, we're going to go into deep space just like our probe. And while that might be cool, we would never see Jebediah again, which is bad. And prograde, as I was saying, means that we would instead be firing while the rocket is facing forwards, and that would increase our speed relative to our trajectory. Okay, so it says 30 seconds. I trust that figure, because that just makes sense to me. The moon is very close now. This is the closest one of these Kerbin have ever gotten to the moon. Their first target away from the planet itself, which doesn't feel like it's that far away. I think relative to how things are in real life, this moon is much closer than our moon is to us. 20 seconds. Unlike when we're trying to transfer to other places, I'm going to wait until the T-minus reaches about 2 or 1 in order to hit the thrust, which should happen about now. Let's take a look at our map right here. We want to make sure, again, our periapse is about 30 or so. 35 is acceptable. Between 35 and 30 is what I'm aiming for. Throttle down so that we don't make mistakes. That we have a more precise approach here. Almost. Aiming for 30s, anywhere in the 30s. Bam! Good enough. Well, you know what? Actually, there, I did a little bit more of a thrust. So now we are in the orbit we need to do all the science that we want to do. And hopefully we have enough fuel to get back to the planet. I'm going to quick save and start to conduct some science. Well, I'll start once we hit below 300, because that's how it was on Kerbin the planet. Also of note is that, well, actually, you know what? I'm going to try this real quick. Since we're now in a stable orbit, I'm going to check our materials bay. 63 science. High over the moon. I'm going to keep the data, and if there's an opportunity to get more data even further down, I'm going to do it. I'm also going to do one of our goo experiments. 22 science. Goo feels right at home. I am going to conduct a temperature experiment with our thermometer. Maybe I should have put it on a lower capsule, or maybe that specific temperature thing applies only if you attach it to a satellite. So never mind with that. We are going to time skip a little bit ahead until we are below 300 kilometers. Watching the moon get closer and closer. It's only a matter of time before we land there. We might even put a base there and have a permanent Kerbin outpost. That would be kind of cool. Since we are below 300, I'm going to try yet another material-based experiment, and if it's the same results... High over the moon... Well, I believe that's what this one said. Let's observe the bay. Yeah, we're just going to keep that, and wait until we dip below, wait until we get to about 30 to try this again. Oh, that is so cool. Actually, it's a little frightening to get this close to the moon without intending to land. Ominous, rather. Okay, dipping below 100, we are cast in darkness. We're gonna try a materials bay observation. Looks like it's the same data as we're getting here. We're gonna review this data, high over the moon. Yep, that's the same one. We're gonna dip even lower. I'm gonna try again below 50 and see what it says. Let's observe this one again real quick. Huh, is that a different result? Oh, did I accidentally... I accidentally reset that one. Okay, well, the only way to find out is to leave this orbit. I'm going to wait until we dip below 40 and then conduct a goo experiment. Right over here. I'm going to review the data just to make sure it's not a repeat. Review this data. Keep the data. We might need to do a lower orbit. I'm not sure, actually. Or maybe we have to do a higher orbit and I don't realize it yet. I'm going to observe this materials bay, high over the moon. Reset that because I believe the other one also says the same exact thing. Okay, so I'm actually going to now warp ahead a bit until we reach the other part of our orbit. And try this again. Yep, that is in fact different data. While high over the moon, and the other one says... Wait. Oh, I think it is repeating, because every time I do this, the other one resets. So I am in fact gathering useless data, I think. Well, it can't be. It should allow me to do duplicate missions, right? Sorry, again, this is an experiment. I'm trying to figure this stuff out as I go along. Observe the materials bay. I'm going to do the same experiment again and see what happens to the one above it. No, this one's still as it is. Alright, well, I'm going to dip below, back to the less than 300, or 30 kilometers. Let's see, I'm going to reset the materials bay on the top one and re-observe it. That is different data. Okay. So we've got all the data, at least for the Science Juniors, at least. I just wanted to make sure. While I'm here, I'm also going to do a mystery goo experiment. And we're going to keep that data. I think we actually have all the data that I can get right... Oh, wait, hold on. I can get barometer readings. Well, of course I want to redo that again. Can't be done right now. Okay. And the temperature? What does the temperature read? Long temperature. We're going to redo the temperature. That gives us 24 science. So, probably better than where I had it before. Alright. So at this stage, there is one more thing we need to do before we can leave the moon, other than to bask in its glory and look at it and be happy that we're here. I'm going to first wait until we're in light like we are right now. There we go. And I'm going to quick save. And actually, let's try one more mystery go while we're here, just for the for the fun of it. High over the moon. Well, no, actually no, I'm not going to. Not yet. We have to conduct an EVA while we're here as well. So first things first, I'm going to quick save right again. We're going to allow Jebediah... Oh, actually, you know what? I should do a crew report while we're here. Let's do a crew report, which gives us an additional 15 science, and I will do yet another crew report when we get closer to the moon. I am going to now do an EVA, where we get an EVA report right here, high over the moon. We're going to keep that data, and then we're going to store the data and take all the data back. Okay. Now we're quick saving yet again, because now we need to go recover this data down here. Let's see. So first things first, I've just quick saved. I'm going to turn on my headlamp. I am going to dismount and press the R key to turn on our jetpack. I'm going to float backwards from it so that we don't get caught. I'm going to start going down by hitting the control key and shift to adjust. Down here we want to collect our Science Junior data, because this lower module down here is not intended to land back on Earth. We can land it back on Earth. I have set it up so that it might be able to, but given our previous luck with the data, I don't feel confident that this module will survive the landing. Real quick, I'm going to collect this one as well. We're going to collect that data. This upper area, I'm not worried about collecting because it's attached to what I intend to land. We can collect it, I suppose, if we want to keep ourselves organized here. But I don't want to risk accidentally getting stuck while out here, so I'm just going to store our experiments here. Oh, careful. Store all of our experiments for the time being. You know what? I'm going to actually take the experiments. And now we are going to lift up slowly, grab our module, and now we're safe. Let's go back inside. We're going to dump one of our experiments because I believe we copied one of our mystery goos. But that's okay. One more thing I want to do before we return is get close enough to the surface and conduct one more EVA to get a different result from Jebediah. Let's see. Oh, and of course we should quick save. So again, around 30 kilometers, or wherein we will conduct one more EVA. We might even do more while we're here, actually, because I believe, like the Earth, the Moon has different biomes, and if we were to stay in orbit, we would eventually get data from multiple biomes if we were clever enough to do that. Unlike the Earth, or rather, Kerbin, we don't have to worry about getting caught in its atmosphere. Like, if we were this low on Kerbin, we would land inevitably because the drag in the atmosphere and their lack of thrusters would cause us to land. Here, the moon has no such atmosphere, so we should be safe. Which keeps us in a stable... We've done several orbits now, so naturally we should be safe. If we're not safe at this point, I'm not sure what would constitute being safe. I'm going to get us to go to about 3,600. I mean, yeah, 36,000. We are going to EVA real quick. I'm going to get Jebediah's opinion on the situation. We're at the Midlands right now. That gives us an additional 24 science. I will drop that data back onto the... we're going to store it right here and then take all the data. So once again, it's all ours. We're going to grab it and get back on board. Actually, let's see if he has anything. If we're... Oh! Moon's twin craters! That's more data! Let's take that real quick. And we're going to store these, but then take all the data back, because that's a trick that lets us do multiple EVAs at once. Let's see if we can actually conduct a few more. I'm going to save real quick. Attempt to do another EVA. Twin craters, we've already done this one. Look how happy he looks. Oh my gosh, he's terrifying looking like that. Ugh. Let's see, we were at the twin craters. Let's see if we can go a little bit further than the twin craters. I'm afraid of skipping time because I'm worried that he'll accidentally let go. Oh, we can't quick save while we've got a Kerbal floating out here like this. So let's connect an EVA. Moon's Midlands, we've already seen the Midlands. We're gonna reset. Well, actually, we're going to leave that. I'll wait here a little bit more until we get to above this distance. Keep trying EVAs just above the Moon's Midlands. Okay. Going to... Actually, we're going to board. We're going to quick save. And I'm going to fast forward a little bit. And see if we can encounter any new biomes while we're still floating above the surface like this. Okay. Let's quick save again. Get Jebediah out. We're going to grab this, of course. We want to conduct another EVA. The Midlands, nothing new. Back on board. There. Let's try yet another one. I'm assuming we're not going to get any new data out of this, but I'll try one more time. And if we don't get any new data here, then I'll just call it. Yep. We're going to reset that experiment. Get back on board. Okay. We have done all these signs that I believe we can do here. So, we are going to get ready to return once more to our dear planet Kerbin. Earth, if you will. In order to get there, we must conduct, I believe, 1 or 2 burns. Let's take a look at our orbit that we have right now. Oh, interesting, that node's still there. Okay, so the Earth, our beloved planet, is over there. And we need to get to the Earth. I noticed that we are in a bizarre elliptical orbit that actually tilts up slightly. I believe that's because of the way we approach the moon. So I'm going to try putting a maneuver point here, going forward like this, and seeing if we can't get a point on the planet that dips us below 300 meters or so. Our periapsis should be there. Retrograde. This is going to be tricky. Oh, hold on. We might have something here. Oops. Maybe if we do an extremely crazy periapsis... No, that's not going to cut it. We need to find a better angle to hit this orbit from. This is going to be a little tricky. Let's try it from the apoapsis. Huh? Hold on, we may be onto something here. What does that put us? 1,000 or so. Oh, hold on, let's look at that. We're going below 1,000,000 kilometers. 31. 156, even better. Wait, hold on. There is no periaps over there now. Is that actually going to put us on the planet itself? 164. 49. Can we get even lower? 18. Oh, that should do it. So this is going to be a very strange orbit. It looks like we're actually launching outwards, then arching around and coming back. I don't know if this is possible. I've never tried something this crazy before. I'm going to quick save before doing this, But if we do this, we should only require one burn to get back home. And it says we need to burn for 50 seconds. I have my doubts about this, but we did quick save, so if anything happens, then this experiment will at least teach us something new and we won't risk sacrificing Jebediah and all of our science to get back home. I have no idea what to make of this, admittedly. There is likely a technique that can be used to safely transfer between two nearby objects like this. That technique is completely unknown to me because I am an amateur. If I knew more than this about orbital physics and rocketry, I would probably be... actually, what was I going to say? Never mind. I'm sorry, I'm rambling at this stage. It says we want to burn for 50 seconds. I hope that's true. Whoa, 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 no, we missed the orbiting point. We are too late. I can remedy this, however. There we go. Also, reasons why you have to be careful about your timing. Timing is everything when you're in space. Okay. Actually, let's try starting now. And take a look at our window here. This looks like a really dangerous orbiting maneuver, actually, because if I fail, it's going to launch me into deep space. Control, control, let's slow down. Slow down, slow down, slow down. Slow down on the throttle. I want to make sure that we get this precisely, because we do need to land back here if we ever want to get home. This is probably the least efficient way to get home. There, 6 kilometers roughly. That should be what we need to get home. Before I quick save, I want to actually make sure that this is actually a system that can work. I know the numbers say it can, but it seems really counterintuitive to actually launch away from the system. I have no idea if this is actually going to work at all, so let's actually find out. I will check our rocketing, and we are on our way. Let's see how this looks from our capsule, just to give us a treat of the moon flying on by as we begin our journey home. Oh, this game is so pretty. If nothing else, then you can at least appreciate the beauty of this game. We are going to go back to our orbital map. Oh. Okay. Oh, I see. Okay, so when we hit this moon escape part right here, we will actually reconnect to the other corresponding Earth capture orb that I see slowly encroaching. It's nice of the game for me to mouse over the moon escape orb, then have a blue orb corresponding to where the moon is going to be. I suppose in real life a lot of these calculations would be done on a computer. There we go. And with the periapse at 6 kilometers in the atmosphere, we should land right on the on our Earth. So, unless something horrible goes on, this should be a successful space mission. Let's recap what we've done so far. We've got a lot of lunar science. Zooming out here, we have our Luna 1 space probe further going out on its own interplanetary mission. And a little bit more closer to home, we have our Sputnik slowly orbiting the Earth. So, we've got quite a few missions going on right now. But it is now time to return home. Let us proceed. Whoa, hold on, what? Did you see that? Did we miss the Earth? What happened? I need to see this one more time. It's a good thing I haven't quick saved. But at 6 kilometers above the surface, I should have landed safely back down. Maybe we were going so fast that we were able to overcome the atmosphere somehow? That's terrifying. Can you imagine something that fast going through your atmosphere? It's like the Chelyabinsk meteorite. Okay, let's observe what happens. This should be intriguing. Okay, so if this works correctly, we should be landing on the lower side of the moon, the Arctic, if you will. Alright, so the music's turned off, which means that it considers us in the atmosphere. Our orbital map is still the same as it is before. I noticed that our number here is actually going down, so perhaps even if we couldn't burn our way out of the situation, we might be able to escape otherwise by just simply being in this orbit for long enough. But of course we want to get down faster. We have only a little bit of liquid fuel left, so I'm a little bit nauseous about trying to do a burn right now. We might be able to, but with this periaps so low, it would probably be a little dangerous. Let me see what would happen if I were to hypothetically do a retrograde right here and now. And get us lower still. Let's see what's happening. Oh, we're getting into the atmosphere again. We are burning. So if this doesn't get us onto the surface of the planet, I don't know what will. So we should be safe henceforth. Let's see. I'm going to quick save because it looks like we are in the right conditions for a Kerbal landing. I'm going to orient the craft properly here. From here on out, stuff should be the same as it ordinarily is as far as landing procedures go. Let's look at our... Yeah, look at that. We're definitely landing back on the planet. I wish I could have sort of seen what would have happened earlier when we were doing our orbit. Somehow this must have happened, but we didn't escape the atmosphere? That's a little terrifying. Okay, it looks like we're going to land in the ocean this time. We are out of fuel on this system. Before we land, I'm going to turn on our landing gear real quick. Our landing gear is up, even if you can't see it because it's really dark. Prior to our landing, just before we get to about 10,000 meters or so, I am going to deploy the lower system. The lower system does have parachutes on it, and it has landing gear on it as well. My hopes is that, with that in mind, it can safely land. So we can at least try to prove that we can land a piece, because we were having so much problem otherwise, a non-capsule piece. We'll see how well that goes. Then I will try to land our own capsule. Let's see. We're approaching the water, it looks like, so we should land at exactly 0 meters. There shouldn't be any topography getting in our way. So at about 10,000 or so... Actually, we're getting pretty close. I'm just going to launch it now. And now I'm going to launch our own parachute. This is awkward. We need to get away from our other... There we go. You know, it's a really good thing that lander can't get caught in our own parachute. Can you imagine how awful that would be if that were to be an actual thing that might happen in the game? Parachute tangling physics. That'd be terrifying. Let's see. Well, now that we're here, we may as well try this again real quick. Gives us 0.1 science, so whatever. Oh, there's the moon that we came from right up there in the distance, right in the galaxy line. I'm not sure if that's the Milky Way in the Kerbin universe or some other galaxy, but oh, that's beautiful. Okay, we are about to land. We could do a crew report, I guess. Oh, 3.5 science, not bad. A little bit more science, barometer pressure real quick. Let's keep that. And let's see if we can do some temperature data from in the ocean. No, I do not want to overwrite the temperature data that we have here. Let's review the data that we got from near the moon. We're going to keep that data, obviously. I might need to add multiple thermometers to our systems. I should keep an eye on where our... I wish we could see where our other debris has landed. Let's give it a moment. Oh, there it is, right on top of us. Okay, I was worried that would be a problem, but it looks like it's good. So this part should be here. I think we've recovered everything that we want to recover. Just before leaving, we're going to quick save. I'm going to see if I can conduct a quick EVA. Well, no, actually, there wouldn't be any point to us doing an EVA, I think. So that's it. I'm going to try one more barometer reading from the surface at the water here to see if we can. We cannot. Okay, we are done with this mission. We're going to recover ourselves. So, from that alone, we've gotten 239 science from our particular mission on our own. So that's not bad at all. Since we have made the effort to land our debris, I am also going... Oh, Luna flight debris? What's this? In flight, Luna... Splash down, splash down. I can't tell which one is the one that we want, so I'm going to splash down, in flight. Let's see. I'm going to try to recover these pieces one at a time and see if any of them are the one that we attached a parachute to. Wow, what's happening up there? Does it not want us to recover this piece? Okay. Yeah, I guess not. We cannot recover. Oh, wait, there we go. It was glitching out, I think. Splash down. Landed at Kerbin. I think this is the one we want. Oh. Whoa, what the heck is happening here? We're fault... Whatever. I think that was thoroughly and through a glitch. That gave us some science, too. That's awesome. Anything else wacky going on here? Splash down. Ah, here we go. No, it didn't give us any science, because we had already recovered it with our Kerbin astronaut prior to launch. Or prior to going. Splash down. I think this is just the remaining leg of our capsule that we left behind. Yeah, it is. Okay. Wait, hold on, what? Mystery Go observation? Oh, that gave us an additional 30 science. Well, I'm glad I didn't forget to do that. Okay, so, sweet. Our lunar orbiting mission was a success. If not a confusing one. So now we have 269 science to blow at this tech tree. Which shall we use? I don't know, actually. Macros, landing mirror. I am going to research this a bit and get back to you guys once I know which one I want to grab. This one's a bit beyond our reach, but these are rover wheels. Rovers might be kind of fun to have. Anyway, I'm thinking to myself at this point. So, until next time, everyone, this is Ardwick. Stay tuned, and good night.